This is an algebra video about expanding and simplifying. When we say expanding, we mean multiplying out brackets. And when we say simplifying, we generally mean adding and subtracting like terms. Although just bear in mind that sometimes simplifying can cover the whole lot of this. Okay, let's have a look at an example. So example 1 is 4 bracket 2x plus 1 plus 2 bracket 3x plus 2. And our instruction is to expand and simplify. Our rules from PEMDAS still stand, so we should still do our multiplication before any possible addition or subtraction. So what I need to do here is first of all multiply the term into the bracket in both cases, and then we'll look at what happens next. So first of all, multiplying 4 by 2x is going to give me 8x, and 4 by 1 is going to give me 4. Next, I've got plus 2 by 3x. That's going to give me plus 6x. And it's very important here that I down plus 6x, not just 6x. I need something to link it on to the rest of the expression. And then finally, plus 2 by plus 2 gives me plus 4. Notice that even at this stage, as I'm saying those multiplications, I'm taking note of the signs. And at this point, it might be a good idea to just remind ourselves of the rules of multiplication of signs. It's not a big deal in this question, but it will be in the future. It's a really good plan to have this little set of notes inside the front page of your copy or somewhere like that, that you can refer to it nice and quickly. We will be dealing with this set of rules for signs very shortly. Like I said, not a big deal in this question, but we'll keep an eye out for it in future examples. So we've followed the expand part of the instruction, and now we have to simplify. So simplifying just means looking out for like terms. So can you spot them in this example? So we have 8x and 6x are like terms, and 4 and 4 are also like terms. Just take a pause for a moment and see, can we remember our vocabulary? What do I call these numbers that have no variables attached? These are called constants. Constants are like terms. What do I call this number in front of the variable? It's the coefficient. Okay, so tidying up. 8x and 6x makes 14x. And plus 4 makes plus 8. That's example 1 finished. We've expanded by multiplying, and we've simplified by adding and subtracting our like terms. Here's a second example. Again, my instructions are to expand and simplify. So first of all, the expansion. That means 3 times this bracket, so 3 by 2a is going to give me 6a, and 3 by 2 is going to give me plus 6. And then moving over to my second bracket, I've got negative 2 by 3a. Now, this 3a is a positive 3a. I haven't just decided that on a whim. If I ever have a term that has no sign in front of it, it's automatically a plus. So negative by positive is going to give me negative. So I'm going to have minus 6a. That's the set of rules up here getting used. Remember, negative by a positive gives a negative. And again here now I've got negative 2 times plus 3, and negative by a positive gives a negative. So that's going to be minus 6. So I've completed the expand part of my instruction. Now I have to simplify. This is an interesting case. When I identify my like terms, 6a and minus 6a and plus 6 and minus 6, what do you notice about the result when I add and subtract them? Well, 6a minus 6a, 6 minus 6, it's the coefficients that I'm working with really, is 0. So I have no a's. And 6 minus 6 from the constants also gives me 0. So I can write my answer as 0. There's nothing left. I can call this cancelling out. The 6a and the minus 6a cancel each other out. The plus 6 and the minus 6 do the same. So 0 is the end result for example 2. Here's a third example. I've got 5 bracket 3x plus 2y minus 2 bracket 2y minus 2x. Again, I want to expand and simplify. Take a moment to write this example down, pause the video, try and do it yourself, keeping an eye on signs, and then play and see if you were correct. Okay, multiplication first. So 5 by 3x is going to give me 15x. 5 by plus 2y is going to give me plus 10y. Minus 2 by 2y is going to give me minus 4y. And then finally, minus 2 by minus 2x, well, a minus by a minus. Let's go back up and refer to this. A minus by a minus makes a plus. So that's going to give me plus 4x. Now I need to tidy up. So I identify my like terms and then I simplify. So 15x plus 4x is going to give me 19x. And plus 10y minus 4y is going to give me what? It's going to give me plus 6y. Don't fall into the trap of using these rules to work out the solution for the plus 6y. These are the rules for multiplying signs. But here, I'm just adding 10 and subtracting 4 to get to plus 6. My solution, so for example 3, is 19x plus 6y. Let's look at example 4. This one looks a little bit different. It still has the same instruction to expand and simplify. But just on first glance, I notice that there's a bracket here at the start. There isn't a bracket at the end. So how do I deal with this? Well, the 6 is at the term directly in front of this bracket, so I'll multiply it in like normal. There's no brackets over here, but these terms are still part of the expression, so they'll just get written on the end, like this. 18a, 6 by 2b is plus 12b, minus 5a, minus 3b. They're still part of the expression, they just didn't have anything to multiply by. Now let's pick out the like terms and finish off by simplifying. So here are my like terms highlighted. 18a minus 5a is going to give me 13a. And 12b minus 3b is going to give me plus 9b. And that's my final answer then for example 4. Here's example 5. Again, example 5 looks a little bit different compared to my first couple of examples. So my instruction is still going to be expand and simplify. And I can see that I have two sets of brackets that I'm going to need to multiply out. But before I begin to do that, let's just quick read through the expressions so that we can kind of get all the detail. So the 2 here is clearly multiplying by this bracket. Then we have this minus 3 plus 2, and then we have this bracket here at the end. Now we need to be very clear in our own heads what we're actually going to be multiplying out to get to the next line. It's really tempting to say minus 3 plus 2 is minus 1, but I don't want to do that. The reason for that is because of PEMDAS. What I'm actually going to do is multiply the 2 by the first bracket, leave the minus 3 alone, and multiply this plus 2 by the last bracket. Remember, multiplication comes before addition and subtraction in PEMDAS. So this minus 3 won't do anything for the minute. It's still part of the expression. I'll still have to write it down, but it's not going to get really involved in the working out, if you like, until the next line. It's important also to bear in mind that we only multiply a bracket by the term that comes directly in front of it. So when multiplying out here, we're going to get 10x plus 2y plus 4. The minus 3 is going to stay there, not doing anything just yet. And then 2 by 2x is going to give us plus 4x. And plus 2 by plus y is going to give us plus 2y. So we've done the expanding part of the instruction now, and now we have to simplify. This means first of all identifying our like terms. So the x's will go together, the y's will go together, and the constants will go together. 10x and 4x will make 14x. Plus 2y will make plus 4y, and plus 4 minus 3 will make plus 1. Let's finish this video with a problem solver. Okay, so first of all, I'm going to tell you that this shape is a square. I'd like you to draw it into your copy and just think to yourself, how could I communicate without any doubt that this was definitely a square? Put in any markings that you need to in the diagram, pause the video while you do that, and then check and see if you're correct. Okay, so if it's definitely a square, That means that all the sides must be equal. So how would I indicate that? Okay, so I've marked in a dash on each side. This still doesn't quite communicate the fact that it's a square. What else should I do? Squares have 90 degrees in the corner, so I should mark in right angles. And in fact, one right angle is enough because that actually implies the rest are all right angles. So you can fill in one, or you can fill them all in if you like. Now I know it's definitely a square. I could, though, if I liked, put an extra little bit of information in. What might this be? I could put in arrows to indicate parallel lines on opposite sides. Okay, so now I've got all my features of my square marked in. I'm going to tell you that I can write an expression down for the side of the square. And I'm going to say that this expression is 5x plus 3. Now, thinking back to what we've learned in the last couple of videos, I'd like you to write down an expression for the perimeter of this square. If you could use brackets as you do this, that would be fantastic. What might such an expression look like? Well, the perimeter, I know, has 4 sides that are all the same length. So I could write its perimeter as 4 bracket 5x plus 3. Could you expand and, if possible, simplify this, please? Well, we can expand it to make 20x plus 12, but we can't simplify it any further because 20x and 12 are not like terms. And here's an extension question for you. Evaluate the perimeter of the square when x equals to 5. Pause the video here, evaluate, and then play and check if you're correct. Well, I know the expression for the perimeter is 20x plus 12, and I'm being told to use x equals to 5, so I'm just going to use substitution and replace the x with 5 in brackets. And I can then evaluate this, and it's going to give me an answer of 112. I don't know what it's been measured in, if it's centimeters or meters or something else entirely, so I'll use units at the end of my answer.